Hey guys, today's video is about classification, which is an important component of data mining. We'll go through the purpose and process of classification in this video. The purpose of classification is to build models that describe the classes of data, and the model can be used to classify unseen data. Don't worry if you feel confused, I'll explain this sentence in detail now. When we build classification models, we actually use training data. Training data is the data used to train an algorithm or machine learning model to predict the outcome. So, training data is only used in building model, not in the evaluation of model. In fact, training data can be labeled or unlabeled. This label is the attribute we want to predict. For example, we want to know whether a person is a student by looking at his or her age, savings, or other characteristics. Then, a labeled training data means we have a group of people and we know exactly which people are students. On the other hand, an unlabeled training data means we don't know whether these people are students or not. We have to build a separate model to group people on our own. Further, both classification and clustering classify unseen data, but classification uses labeled data. Clustering uses unlabeled training data. To have a better idea, labeled data look like this. In this case, we have two labels, blue and orange. However, unlabeled data look like this. We only see the characteristics of data points, which are x and y axes, but we don't know which groups they belong to. Therefore, we need to derive a model to group training data. Different models can generate different results. For example, these two results are both reasonable grouping, but there are some measures that can be used to examine the quality of grouping. Last, a machine learning method is supervised when the training data is labeled, and is unsupervised when the training data is unlabeled. Alright, now we understand what the foundation of our model is. Then, the classes or labels are categorical. To be more specific, the classes are nominal or binary, since binary is just a special case of nominal data. For example, our model may predict whether a person is going to buy a computer, but it cannot predict the height of a person since height is just numeric data. Next, model is also called classifier because it divides unseen data into groups. Last, classifier predicts the class label, not the number. In fact, there is a clear boundary between classification and prediction. Classification predicts discrete labels, and prediction predicts continuous numeric data, so they do not refer to the same thing. As we said before, discrete label is categorical. Gender is an example, and continuous data is typically numbers, and height is an example of numeric data. Let's talk about the process of classification. There are two important steps. The first one is training phase or learning phase. It refers to the process of building a model from a labeled training set. For example, we have this training data. Each data has three attributes: gender, height, and weight. Gender is the target label we want to predict. That is, the model predicts the gender of a person given his or her height and weight. One possible model is that if a person is higher than 170 centimeters and heavier than 70 kilograms, then that person is a male. Of course, this model is not so accurate because we only have 3 samples. However, if you apply the model to the training data, you may believe that the model works fine. To be more specific, in our database, individual who is taller than 170 centimeters and heavier than 70 kilograms is indeed male. Then, the second step is evaluation and classification. We evaluate the model on testing data, and if the model works fine, we apply the model to classify unseen data. For instance, we have 2 samples as test data. One is a male who is 168 centimeters and 70 kilograms. Another is a female who is 172 centimeters and 60 kilograms. If we use our model, these two people would both be classified as female. However, one of them is a male, so the model only has 50% accuracy. In other words, the model can predict 50% of labor correctly. If you think about this, you will find this model totally unacceptable. Because if you just do a random guess or you just flip a coin, you will also get 50% accuracy. If the model is just as good as random guess, why would we even bother to use the model? Therefore, in this case, we reject the model and don't use it. Another important thing is the difference between training data and testing data. Training data is only used in step 1, and we can't use training data in step 2. Because the whole model is based on the training data, it's unfair to use this data to evaluate the performance of model. On the other hand, test data is only used in testing, which is step 2. Testing data must be labeled. Since we need to know whether the model do the prediction correctly, we must have the answers beforehand. Last, there are a lot of measures that can be used to evaluate a model. For example, accuracy is like how many % of testing data does the model correctly classify. Speed is how fast the model completes the prediction process. Interpretability is to what extent can humans explain the model. Scalability is the model's ability to handle large amounts of data. These are 4 popular measures in evaluating the model's performance. Alright, that's pretty much the introduction to classification. We'll talk specific methods or algorithms in the following videos. Thank you for watching my video and see you next time.